This video covers service chain redundancy, a new use case supported in Control 3.0. As you are about to see, this use case is possible thanks to two new features: routine policies and service health check. With routine policies, you can filter and modify routes in a fine-grained manner. For example, you may want to only allow certain routes or to add BGP attributes to a given prefix. Okay, let's see how this scenario works. Subscribers in the left VRF try to access the internet on the right VRF. The service provider steers the traffic through a service chain composed of a firewall and a NAT service. Each of these services is a VNF or virtual network function implemented through a service instance. One service instance can be a virtual machine or a container or even a physical appliance. In order to protect against failures, we deploy two functionally identical service chains, each on a different control cluster. It is possible to configure one of the service chains as primary and the other one as backup. If the primary service chain fails, the backup service chain takes over. The original scenario involves two different data centers. In this video demo, we have simplified the scenario a bit in order to make things easier to follow. First, we have connected both control clusters to the same IP fabric. Second, the subscriber is represented by a loopback interface at the data center gateway VRF. Finally, we have split the data center gateway function in two devices, gateway 1 and gateway 2, each with a single VRF. This is just a way to show a simple scenario, but the original use case shown in the previous picture is fully supported. In this picture, there is only one gateway on the right, but it is perfectly possible to have more of them for redundancy. These external gateways advertise a default route to both clusters in the context of VRF write. The default route carries a route target, 65,000:10,002, and, for the sake of the example, also a regular community, 65,111. The control clusters are a bit simplified. In reality, each cluster typically has several control nodes. Finally, the firewall and NAT functions inside a cluster may also run in different compute nodes. Both clusters leak the routes to the left VRF as part of the service chaining usual mechanics. Control 3.0 introduces the possibility to apply routing policies and in this way influence the leaking process by filtering or modifying prefixes. In this case, the policies are carefully designed so that cluster number 1 leaks the route with a higher local preference, in this case 500. On the other hand, cluster number 2 leaks the route with a lower local preference, 250. As a result of the different local preferences, flows are steered through the service chain in cluster number 1. In other words, cluster number 1 contains the primary service chain. Now, if the NAT pools configured on the two clusters are different, flow symmetry is guaranteed and the return flow also goes through the service chain on top. Now let's imagine that the firewall 1 instance is black hole in the traffic. Another new feature in Control 3.0 allows to perform a health check on the service instance and detect the failure. Once the failure is detected, the control nodes in cluster number 1 stop advertising the leaked routes. This automatically redirects the traffic through the backup service chain. When the firewall 1 instance recovers, the primary service chain becomes active again. It's time to see the feature in action. The left terminals in blue are connected to the external gateway on the left or subscriber side of the world. The two terminals in the center are connected to firewall 1 and firewall 2 respectively. Finally, the terminal on the right, in pink, is connected to the Internet gateway. The Internet VRF gateway advertises the default route with identical attributes to both control clusters. The subscriber gateway receives the leaked route with different local preferences. so it prefers the route advertised by the control node in cluster number 1. See the star that identifies the active route in Junos. When the subscriber pings an address in the right VRF, the flow is created in firewall 1 as expected. Then it times out and disappears. Let's leave the ping running and monitor the flows on firewall 2. For the moment, no flows in firewall 2 as expected. Now we activate a filter term in firewall 1. This causes traffic blackholing and triggers a service chain switchover after a few seconds, as specified by the service health check timer configuration. After some packet loss, ping resumes and flows start to be created in firewall 2. As expected, the subscriber gateway no longer receives the default route from cluster 1, and the route from cluster 2 becomes active. Now let's get firewall 1 back to the normal situation. Things go smooth. The primary service chain becomes active again and ping continues normally. Let's look at the overall ping statistics. We see some packet loss corresponding to the previous switchover from the primary to the backup service chain. This is due to the service health check timers configured. As for the fallback to the primary service chain once firewall 1 recovers, it was completely hitless. After showing the feature in action, let's go quickly through all the configuration steps in cluster number 1. You can see the configuration of the service chain by browsing our channel. Look for a video that covers the port tuple feature. Okay, let's focus on the service chain redundancy specific configuration. At this point, we have a functional service chain. Now we have to make it the primary service chain. First, we configure a routing policy that we call LP500. Routing policies can have several terms, and each term matches different conditions and can execute several actions. We act upon routes which carry the 65000:111 community. Remember, the default route in our example has this community. We also specify protocol service chain, so the term is specific to leaked routes. Next, we apply the routing policy at the leftmost interface of the service chain. And at this point, the service chain in cluster number 1 becomes primary. Last but not least, we also need to configure service health check objects in order to detect traffic blackholing. With these timers, we can expect a detection in about 5 seconds. Now we apply the service health check object to the leftmost interface of the service chain. And it is also possible to attach it to the rightmost interface. The configuration in cluster number 2 is very similar. We just need to specify different subnets and the lower local preference value. Thank you for watching this video.